Hey everyone, welcome back. Today, we're diving into a groundbreaking advancement in medical AI, SAMed-2, a model that's reshaping how we analyze medical images. Ever wondered how doctors identify tumors in CT scans or track organs in MRIs? It's all about segmentation, the process of isolating specific structures in an image. But here's the catch: medical images are messy. They're noisy, varied, and constantly changing. Traditional AI models struggle with this complexity. Let's break it down. Most AI today relies on huge datasets to learn patterns. But medical data is different. Think of it like trying to learn a language from a chaotic classroom. Different teachers, overlapping conversations, and unclear instructions. That's why existing models often fail when faced with new tasks or imaging techniques. They forget what they've learned or get confused by noise. Enter SAMed-2. This model is like a supercharged version of the Segment-Anything family, but with a twist. The researchers behind it didn't just tweak an existing system, they built something new. Their secret weapons: a temporal adapter and a confidence-driven memory system. The temporal adapter is like a time machine for images. Medical scans aren't static, they're sequences. Think of a CT scan as a stack of slices, or an MRI as a moving video. The temporal adapter helps the model see how these images change over time, capturing patterns that a regular model would miss. Then there's the memory system. Imagine a librarian who only keeps the most reliable books. SAMed-2 doesn't just store every piece of data it sees, it selectively remembers the most confident predictions. When it encounters a new scan, it pulls up these trusted memories, compares them to the current image, and makes smarter decisions. This stops the model from forgetting earlier tasks and helps it handle noisy or unclear data. But how did they test this? They created SAMed-100K, a massive dataset spanning 7 imaging types, like X-rays, MRIs, and ultrasounds, and 21 different segmentation tasks. It's the medical equivalent of a universal language test. And the results? SAMed-2 outperformed existing models, especially in zero-shot scenarios where it tackled tasks it had never seen before. In fact, it improved external test results by a stunning 10.53%. So why does this matter? Better segmentation means earlier disease detection, more precise surgeries, and personalized treatment plans. Imagine a world where AI doesn't just analyze images but understands their stories, over time, across modalities, and with unwavering focus. That's the future SAMed-2 is helping us build. Thanks for watching. If you want to explore the code or dive deeper into the research, check the description. Stay curious, and we'll see you next time. Imagine a world where doctors can analyze medical scans in minutes instead of hours. That's the promise of SAMed-2, a groundbreaking AI model designed to revolutionize how we segment medical images. Let's break down what makes this technology so special, and why it's a game changer for healthcare. So what's the problem here? Manual annotation of medical images, like slicing through a thyroid ultrasound or mapping a tumor in a CT scan, is incredibly time-consuming. Back in the study, researchers found that experts spent an average of 609 seconds per frame just to mark up images. That's over 10 minutes for a single slice. But SAMed-2, it cuts that time down to just 75 seconds, an 87.6% reduction. Think of it like upgrading from a hand-drawn map to a GPS that updates in real time. How does it work? SAMed-2 builds on a model called SAMed-2, which was already a big deal for its segment-anything capability. But medical imaging has unique challenges, like noisy data, varying image types, and the need to track structures across multiple frames, like a video. SAMed-2 solves this with 2 key innovations. First, it adds temporal awareness. Imagine watching a video of a beating heart. Traditional models might analyze each frame in isolation, but SAMed-2 looks at how structures change over time. It's like recognizing a car in a video by tracking its movement across frames, not just guessing from a single photo. This helps the model understand context, making it far more accurate for dynamic medical data. Second, there's the confidence-driven memory mechanism. This is where the magic happens. The model doesn't just memorize every detail, it learns to prioritize reliable information. Think of it like a student who studies smartly, focusing on the chapters most likely to appear on the test. By training on a massive, diverse dataset called SAMed-100K, SAMed-2 identifies which features are most trustworthy, ignoring noise and adapting to different imaging styles. This makes it super robust, even when dealing with tricky cases. The results? SAMed-2 isn't just faster, it's smarter. It bridges the gap between segment-anything, AI, and the real-world demands of clinical settings. Whether it's a 3D MRI scan or a video of a patient's organs, this model adapts seamlessly. And for doctors, it means less time spent on tedious tasks and more time focusing on what matters: patient care. So what's next? As AI continues to evolve, tools like SAMed-2 could transform everything from diagnostics to surgery planning. The future of medicine isn't just about better tools, it's about smarter ones. And that's a future we're all excited to see unfold.